Thank you for joining our webinar, 5G, a review of the global patent landscape. My name is Brian Costello, Marketing Manager for Clarivate Analytics, and I'm excited to be joined by our presenter, Ed White, Director of Patent Analytics at Clarivate Analytics. I'd like to welcome Ed to our presentation. Ed?
Thank you, Brian. Welcome, everyone, to this pop-up webinar. I'm going to be covering today a summary patent landscape on the 5G space. This is a patent landscape study that we recently presented at the IP Business Congress event in Boston. This landscape is based on work that the Derwent Services Group recently delivered to the Taiwanese Intellectual Property Office. And so therefore, right up front, it is a really big thank you to them that we're able to share the insights that this landscape provides to you today. 5G is a really big topic. It's one that all of us have heard of, but it is one that not all of us really understand what it actually is, and probably more importantly, what it means. For those of you in the telecommunications industry, you're likely on top of those questions. However, what is intriguing about 5G is that its impact is not going to stop at smartphones. Over the next 15 minutes, I will be getting into the detail of the landscape, describing what 5G actually is, who is producing it, and where it's headed. As Brian mentioned at the top of the call, if any of the slides provoke a question in you, please do submit it into the Q&A box, and then at the end of the slides, we will answer as many of them as we can. So at a basic level, 5G is a series of new telecommunication standards and underlying technology supporting those standards that will vastly increase the data rates and capacity of mobile data infrastructure. Those standards at this point are almost all now in place or shortly will be. In fact, the first 5G networks are actually going live as we speak. From the perspective of a consumer with a phone in their hand, like me, watching YouTube on the tube home from work, on the train home from work, on their daily commute, they are going to see significantly better speeds, download speeds, and significantly better response time from websites. All of this is coming from technologies within the 5G realm that build upon cellular networks installed over the last 20, 25 years. But what is different about 5G compared to 4G or even 3G or 2G and everything that went before? There's actually a few different answers to that question, but some specific technologies include things like a shift to higher frequency bands, a change in the way that the local cell phone tower will link to your phone. So, for example, instead of broadcasting a wide signal across the whole cell, a larger number of smaller antennae will use things like beamforming technology to concentrate a signal directly to your device. In addition, the capacity of each cell is much, much higher, supporting potentially millions of over-the-air connected devices, compared to now, where only a few thousand are supported. Most of these technologies are iterations. They're combinations of tech that's partially included in previous standards, but are now all being brought together. The hardware and back-end infrastructure of 5G really does involve new equipment. Essentially, this is going to be a new parallel mobile data network. It will mean you would need a new phone, for example. But in addition to the consumer, the massive increase in capacity means that 5G will support a number of side links or modes that specifically support machine-to-machine, device-to-device type connections. These modes swap the very large download-upload speed with, for example, very high reliability communication. For example, if you think about between vehicles or vehicles and infrastructure, the V2X type use case, they don't need to be able to download all of Season 8 of Game of Thrones in a few seconds, but they do need their connection to be on all the time. This is really the paradigm shift of 5G. It creates a backbone data infrastructure that uncouples data-producing or data-consuming devices from wired connections, meaning anything that benefits from a data connection, but the cost of the last mile of a wired connection to it was previously untenable, can now benefit. 5G will do for unsmart devices what the internet did for commerce or what 2G, 3G, 4G mobile phone networks did for smartphones. Where that ultimately leads is obviously a little bit difficult to answer, but we know that from previous advances in connectivity, companies, inventors, innovators will take advantage of more bandwidth. So to the patent landscape, what does it look like? Well, first of all, growth is very evident. The patent data sphere within 5G has increased by about 700% over the last 5 years. Normally, when we see that level of growth, we also see some fragmentation, but in 5G, that growth is not giving way to a fractured IP ecosystem. Instead, 6 firms are associated with more than 40% of the inventions in 5G. 6 companies whose names are from the media now very familiar to us. More than that, when the inventions in the landscape are assessed for desirable characteristics, things like impact, validity, technical and geographic breadth, those 6 firms' share of the very strongest inventions goes over 50%. In other words, the majority. One of the key aspects of 5G that makes it different from 4G is that much of the base technology and innovation has come from the Far East, causing a change in the patent licensing environment for the telecommunications industry. However, the patent landscape shows us an interesting picture, a more nuanced picture. The fastest growth in patent output right now is coming from the United States and Europe. Those of you that perform patent research on a regular basis will recognize that this is not typical. In fact, as of December, Europe and the US, when combined together, account for more 5G patent output than China, which, when Chinese filing patents are taken into account, is a little surprising. Going a little further, one of the more useful aspects of deep patent analytics is the ability to model markets. What we're going to do here is array the portfolio strength of the top 50 invention holders against the age of those portfolios and their volume. The strength that we are modeling here is based on a metric we call the Derwent Strength Index, and it looks specifically at, as I said before, the validity, the investment levels, the technical breadth, and the downstream impact of patented inventions. All of those factors are then weighted for age. The y-axis of this model is increasing average portfolio strength, and the x-axis is decreasing average portfolio age. If we start by highlighting our top 6, Samsung, Intel, Huawei, Ericsson, Qualcomm, and Nokia, we can see that they sit in a strong position in the model, above average patent rights and fairly central in time. In other words, exactly where you would expect them to be. As they represent 40% of the landscape, we do need to take into account that to a degree they do define average values for the model. But we can look elsewhere. We can look at the high patent volumes that come from primarily Chinese academic institutions, and we can see that their impact on the landscape is somewhat limited, mostly within the lower half. The exception to this is a strong early portfolio from ETRI in Korea. We can see the automotive component, the V2V, V2I, V2X use case. It is evident with automotive firms in the top 50 model and here quite early. And then finally, we can model the newer, stronger members of the top 50, the ones to watch as they represent change in our landscape, both technically and competitively. Here we see a mix of handset manufacturers, carriers, and entities like Afino and Comvida. But really, the real outlier is HTC. We can see here it has a smaller 5G portfolio, but it is the portfolio out of the top 50 that best combines youth and strength. But going back to one of my original questions, what exactly is 5G technology? Is there a way to tell what is at its heart? Our technique is to focus on the big 6, and to look at where their focus of patent activity is across a whole host of 5G enabling technologies and use cases. If we do that, three fields stand out: antenna technology, handover technology, and resource management. All three of these speak to the core of 5G in terms of directed signal and the complexities that come with so many more cells and so many more devices to handle within those cells. My apologies. This is where the most lucrative patent rights will be: the antenna, the resource management, the handover. This is where the most highly lucrative patent licenses are likely to be, as these technologies represent really what enables 5G to be successful. Everything else within 5G will rest upon them. To produce these analyses, we need to mine the patent landscape for all of these different technical approaches. And once you've done that, you can lean on them for more detailed metrics on our next slide. So we can look at overlap. And via the lens of overlap, we can get a view of concentration and of gaps. The gaps are really interesting because despite 700% growth, seven-fold increase over 5 years, there are still opportunities to develop and own portions of the 5G space. And we've highlighted a few here, but some of them you can see are, for example, full duplex mode transceivers. These are transceivers that can transmit and receive simultaneously and thereby double capacity on the network. Or, for example, cell-less 5G architecture, which potentially will become important in the Internet of Things environment. This data view also shows us the primary use cases at the moment: the machine and vehicle side links and applications of 5G in things such as utilities and smart homes. We could use our earlier directionality modeling technique to get a look at the direction of 5G as a whole via our data mined categories. The earlier model we looked at focused on the competitive dynamics. Now we're going to look at the technical dynamics of 5G. So we have our different categories arrayed again on strength, volume, and time axes. The way that this model works is that it tells you not just where 5G currently is, but where 5G is headed, and so much so that we actually call this our crystal ball view. If we divide all of our categories into three types: the underlying technologies, the industrial uses, and the 5G use cases, and review just at that level, just on that basis, it provides a really good overview of the directionality of the industry. The top left-hand corner, the strong, older technologies, is where the core technologies that enable 5G to work sit. This is resource management, handover, and antenna technology that we mentioned earlier, further confirming their importance to 5G. The top right-hand quadrant is where 5G is headed, and right now it is mostly application areas, indicating current global 5G innovation is focused on diversification of 5G, rollout, essentially. It's probably important to note that the uses of 5G in the top right-hand quadrant do not include the automotive use cases, the V2X space. Those are squarely within the older, stronger bracket. And then if we go one level deeper, we get into the individual technical categories themselves. And if we go into this, we can see one technical approach sitting within our top right-hand quadrant, which is network virtualization, showing us a topic that is currently at the forefront of IP rights seeking. In the bottom right-hand quadrant are the very young but not yet strong technologies. This is the bleeding edge, so to speak. This is where we see the pointers to further evolution of the telecommunication standards, the use cases and specific techniques for machine communication, and more exotic technologies such as polar channel coding and network slicing. These are fields to keep an eye on. Are these pointers on the road to 5.5G or even 6G? We shall see. But what is common to this directionality analysis is the Internet of Things ecosystem, machine-to-machine communication. All of this analysis gives us a good indication of the flow of 5G development. There is a clear generational phased process going on within 5G. The first phase was initial network development and a simple, in inverted commas, swap out of 4G infrastructure to enable faster speeds and connectivity for smartphones. The next stage will be the first generation of Internet of Things, connectivity of devices in transport, in the home, in the city, and in utility supply. The second generation of Internet of Things, things like agriculture, industrial automation, and retail, is still being formed. And in fact, the technology to support those more exotic uses is, from the looks of it, not yet that mature. That means that there is a lot of opportunity here. All of this also provides insight into the issues surrounding IP management of 5G, specifically the complexity of the technology behind 5G, the fact that 5G enables an order of magnitude increase in supported devices per cell, and the explosion of industrial applicability. All of that can be distilled down into one short finding. Telecommunications and access to telecommunications as a market is going to get much bigger and much, much more complicated. This has a very large implication on how commercial entities will gain access to technology, for example, within the patent licensing space. In 4G and earlier phases, early generations, telecommunication patent licensing is essentially a stratagem within the telco infrastructure, handset, and carrier companies. In other words, the companies that developed that system over a long period of time and are fully set up in terms of business model, knowledge, processes, and staff. 5G extends that to many more types of entities, to utility companies, to municipal governments, highways agencies, retail companies, companies involved in industrial automation. There is probably quite a lot to develop, probably quite a lot to learn, and this is going to be a very evolving picture.
As promised, we're going to take the next 10 minutes or so to answer your question. Our first question is this type of analysis specific to telecommunications or 5G? Can you do it on other technologies or industries?
That's a very fair question. Yes, the frameworks that we're using here, things like strength modeling and competitive and technical dynamic modeling, all of them work on many, many different subject matters. Probably the only requirement we need is that it likely needs to be a patentable subject matter, but this works in chemistry fields, in pharmaceutical fields, in pretty much in automotive fields, aerospace fields. It works in them all. That's a good question.
Very good. Why isn't Apple active in the patent landscape for 5G?
They are active in the patent landscape for 5G. In fact, they were identified as one of our ones to watch. They are somewhat central in time, but they don't have the biggest portfolio, but they do have one of the highest scoring. But they are in fact there.
Are there any standard essential patents available for 5G?
So standard essentiality, this is a great topic to get into. The answer to that is almost certainly yes. And in fact, this is a topic that telecommunication companies will be working on right now. 5G licensing is taking place. For those of you who are not familiar with standard essentiality, it essentially means whether a patent reads onto components of the standard, and therefore anybody using that standard is by definition using that patent. There is a difference between standards declared patents and confirmed standard essential, which is essentially one of opinion, I guess you would say. But yes, there are standard essential patents within 5G already.
Okay. How do you define a strong or weak invention?
It's a great question. One that I think we predicted would come up. We look at quantitative metrics that look at essentially real-world desirable characteristics of a patent asset. We look at whether it's granted and how many different places it's been granted. That is a proxy for both confirmatory validity to an extent and also a proxy for how committed the applicant was to getting that patent granted. We look at the frequency of citation to the family, the invention, essentially, based on a Derwent definition. That is a well-known indicator of impact of relevancy to downstream development, and one that is useful, but is particularly useful when used in combination with other factors. We look at how many different countries and jurisdictions the applicant filed it in. There is a difference between a telecommunication patent filed in 12 countries and one that's just filed in a single jurisdiction. We look at how many different technical disciplines the invention reads across. So is it in communications, but also in a healthcare category, and also in a data processing category, and also in a automotive category, means that we're looking piece for piece at a bigger patent. We take all of that together. We do a reasonable amount of modeling for age, because many of those factors don't exist on day one. And then we look at all of the cohort within the same model. So it's a relative ranking just for the cohort that we put through that strength measurement process. There is a lot more nuance to it, as you can imagine, but essentially it is a way of looking at not too many and not too few factors that have a real-world relevance, and not just a regression-tested data point.
Okay, very good. How much of the Big Six's 5G portfolio comes from 4G development?
That's a difficult question to answer. I would say that almost everything in 5G is a development on 4G. Because this is, as with all technical development, it is an iterative process. The topographies of how signals are multiplexed and coded, the antenna technologies, the way the software systems for handover and management of signals and bandwidth, all of it comes probably originally from first generation, second generation, fourth generation mobile telephony, as well as a whole host of other technologies that are out there. So how much of the 5G portfolios of these companies comes from 4G development? There's one argument to say almost all of it.
How are 5G patents identified?
That's a really great question. So the technical categories that we were looking at look for use cases or niche technologies that do not form part of the current or pre-5G standards. And that way we're looking at enabling technology that's specific to 5G, and then we will create a whole host of search strings around them, as well as looking for mentions of the standards and various standards bodies that have different names for 5G. So it's a process of putting together probably somewhere in the region of 30 to 50 search strings that look for specific facets that we know that 5G entails. So we would be looking at orthogonality in multiple access schemes. We'd be looking at beamforming antenna technology, massive MIMO antenna technology, and so on and so forth. Wrap all of that together, that gives you our definition of 5G for the purposes of this landscape. But almost every landscape that's produced is going to have a different viewpoint. It's going to have a different reason for its existence. The questions that are going to be posed of it are different, so it will have a different base data set. There are, for example, in a licensing context, probably going back to the question of how much does it rest on 4G, probably quite a lot. So if you're involved in a licensing discussion, you will want to bring in a lot of 4G technology into your landscape. But essentially, it is via lots of different ways of digging into the Venn diagram of 5G via multiple search strings.
Are the data sets based upon granted patent rights only, or do they include pre-grant published application data as well?
Yes, they do include both applications and grants, and that's simply for the basis that the pendency period is so long that if you only relied on granted patent data, you'd be waiting a long time for a complete picture. Secondly, applications don't grant not just because they're not valid. They grant because maybe it wasn't worth it. The invention was too small. So we do look at both. We come at this from the perspective of patented inventions, and that definition means filed, applied for. And then we use whether it grants or not as an additional data point rather than a restriction.
A couple different questions here about activity in Asia, and what do you think of the reports that claim that China is the far and away leader in 5G? And is there activity in Asia that may not be patented, ergo trade secrets?
Well, so that's a good question. I'm not sure that the empirical data backs up the view that most of 5G is Chinese. I'm also, while trade secret is obviously it's likely to exist within telecommunications technology, but there is a motivating factor to patent, and that is that the technology within 5G is extremely lucrative for patent licensing. And in fact, it's one of the primary routes to commercialization and monetization. There's probably more to be done on trade secret side on the device layer than on the infrastructure layer. But if 5G as an infrastructure, if you owned or had developed technology, I think you would be highly motivated to patent it. And in addition to that, you'd be highly motivated to patent it in legal jurisdictions in which you wanted to enforce for licensing purposes. So that means potentially not just filing in China, but also filing in Japan, in Europe, in the United States. So it's a good question. I don't think that we will ever fully know. I don't think anybody fully knows whether something's been held trade secret because it's a secret. But in this case, I think we can have a fairly high level of confidence that we do have a good picture of what's going on within 5G.
Okay, great. We have a ton of questions, but since this is a pop-up webinar, we're going to come to a stop here.
Thank you, everybody, for coming along. We appreciate your time, and yes, have a good rest of your day.